In the last lesson, we looked at how to calculate an optimal value. Today, we're going to start using them some more. So just quick refresher. We have two choices, well, three choices, suppose. Vertex form you can just look at. But factored form, you can average your zeros. Standard form, you can use negative b over 2a. Either way, plug it into your equation and find your optimal value. So let's try one real quick. And this is factored form. We'll do the quick way. And our zeros are -6, -8. Our axis is symmetry then would be -6 plus -8 divided by 2, which is -7. Plug it back in. Calculate. And we get -1. Is it a min or a max? Well, the a value out front this time, or x times x, which makes x squared, still 1. Tells me it's a min because it opens down. Min of -1 when x is -7. Standard form 1, our axis is symmetry, we can do negative b over 2a. There's b, there's a. So -12 over 2 times 1, which is -6. And y would be -6 squared plus 12 times -6 plus 10. Into our calculator, we get -26. Okay, our a value is a +1, which means it's a min of -26. And x is -6. Okay, the two things we looked at yesterday, we're just going to start working with those. Now, in case you didn't notice, there was a printout you could use with this. It's a handout of the word problems. You have to spend time writing them out. Spend time working on them. Okay, but if you haven't printed out, you can just follow along with the video. So some kinds of problems we should be familiar with. Numerical problems. Ones just involve numbers. Okay, the sum of two numbers is 49. Their product is the maximum. I don't know what the numbers are. I'm being asked to find that. There's my let statement. Let x equal the first number. Okay. Second number, I could write down y equals. That's fine if you want to do that. Or the fact that we know they're related to each other, they add up to 49, you could say 49 minus x would be your second number. And that's an option. If you don't want to do that, that's okay. We'll teach you both ways. The product is a maximum. How do I find product? Product means multiply. So x times y. Or in other words, x times 49 minus x. How would I get 49 minus x? Well, I know that x plus y is 49, right? That's what it tells me here. So if I want to figure out what y is, I can say, well, it's 49 minus x. Then I can plug it in. I want to solve this. I want to find what makes them a maximum. I'm looking for an optimal value. The best way of doing this, I suggest, is let's do it in standard form. It just makes life easier. So if we expand our brackets, we have things in the right order. I want to find the maximum value. Standard form tells me use negative b over 2a. So x equals negative 40a 9 over 2 times -1. Or in other words, 24.5. Once I know x, I can get y. How can I get y? Well, I could either use 49 minus 2x or 49 minus 2x. That's how the numbers are related to each other, right? So 49 minus 24.5 gives us 24.5. Therefore, the two numbers are both 24.5. Okay, there's a word problem, a simple one. Okay. If we can, try and use one variable. If you can't, you're going to have to rearrange to substitute to use one variable. That's the option. Let's look at the next one, money problem. Something we spent a lot of time on in grade 10. They always get set up the same way. Money problems involve revenue. How do you create revenue? You sell something for a certain price, and you sell a certain number of them. So the way we used to set this up was, what was your price? What were you selling? We're looking at a high school basketball game where the admission price is $2. Oh, $2. In a championship game, admission prices will increase. They're going to go up. How much? 20 cents every time I change the price. So in money problems, X always refers to the number of changes. Maybe they're going to increase the price once, or twice, or 10 times. We don't know that. That's where the X comes in. That's our price. How many people attend? 500. How does that change? Every time we increase the price, we lose 20 people. Now again, we might change the price once, or twice, or 10 times, so we need the X in there. I want to know the price that's going to maximize my profits. I'm looking for the optimal value again. Now, this is factored form. If you want to work with factored form in zeros, you're more than welcome to. Or we can FOIL this. Put in standard form, use negative b over 2a. It's totally your choice. I'm going to do both right now just so we can see, okay? So let's do the zeros way first. So I can't see, so I solve. So 0.2x equals negative 2, x equals negative 10. 500 minus 20x equals 0. I can't see, so I solve. 500 is 20x. X is 25. Axis is symmetry. X equals negative 10 plus 25 over 2, which is 15 over 2, which is 7.5. So I'm going to produce the best price when I change it 7.5 times. Remember, X is your changes. I'll go to the price in a second, but I also I want to do this both ways. So method 2 is method number 1. Okay, method 2 is that's FOIL. So 2 times 500 is 1,000. 2 times negative 20 is negative 40. 0.2 times 500 is, what's that, 10? And 0.2 times 20 is negative negative 4 x squared. Okay, put in the right order. Cut to our like terms. Got negative 4x squared, oops, minus 30x plus 1,000. Axis is symmetry. We're going to use negative b over 2a, right? So negative b would be positive 30 now over 2 times 4. Negative 4, sorry. I think I have a sign mistake in there somewhere. Hang on 2 seconds. Negative, positive, negative. One of these has a sign mistake in it. All right, there's a mistake. Sorry, I got to fix this. It wasn't 10, it was 100. Yeah, so we got to fix real quick. Plus 100x. So when I collect this time, it should actually be 60x. Okay, so there we go. Back to what we're doing. Negative b over 2 times a. So again, negative 60 over 8, which also comes out to 7.5. So your choice on how you want to approach this one. Do you want to use zeros? Do you want to use standard form? Either way, x should be 7.5. The question was, what price will maximize our profits? Our price comes from this part of the equation. Price equals 2 plus 0.2x. Just write that down. Price equals 2 plus 0.2x, where x refers to how many changes to our price we should make. We said there should be 7.5 changes. So if we do that, we'll get 2 plus 0.2 times 7.5, and we'll get an answer of 3.5, or $3.50. Okay, so to optimize profit or revenue, charge $3.50. Okay, that's a money problem, standard kind of money problem. We did lots of those last year. Yeah, the one you might not spend so much time on in grade 10, shape problems. In shape problems, which are kind of like numerical problems, except we have a shape to start with, we're often going to have 2 variables. We want to try and make it into 1. So if we examine this thing here, we have a rectangular field divided as shown. The farmer has 160 meters of fencing. We want to figure out the dimensions to get the maximum area, the optimal area. So we don't know what the different sizes are. I'm going to call these x's. I'm going to call this y. I don't really have a choice here off the bat because I don't know how these things are related to each other. I need to start with two variables. But I know that our fence is 160 meters. In other words, our perimeter, which is 4 x's and 2 y's, comes out to 160. I've got two variables. But I want to maximize my area. How do I find the area of this rectangle? Length times width, x times y. So if I can get one of my letters by itself, I can substitute and rearrange and solve. I want to get either x by itself or y by itself. I think it's easier to get y by itself because I can divide by 2 easier than I can divide by 4. And here's what I mean. If I rearrange and then I divide everything by 2, I'll get 80 minus 2x has to be y. And then I can take this and plug it in here. So I end up with an equation, x times 80 minus 2x, which is a quadratic. And if I expand that and put it in the right order, I now have an equation for a quadratic, the area of which, based on x. I want to maximize my area. I want to optimize this. Let's try it. How do I find the axis of symmetry in standard form? Negative b over 2a, which comes out to 80 over 4, or just 20. How do I get y? Back into y, right? So 80 minus 2 times x. This is x. That's y, and y is 40. Therefore, there's a maximum area when x is 20 and y is 40. And that's how a shape problem works. Okay? You start with two variables, so you can plug one equation into the other. Here's our last example. I'm going to get you guys to try it. Same kind of question, so you have to try this one. So pause it, see what you can do. We've got Wendell wants to build a pen for his animals, 60 meters of fencing, but we got a river on one side. So here's a river. His pen has to go here. So we know x and y and x. We know our perimeter is 2x's plus a y, and we know it actually comes out to 60. We want to maximize our area, which kind of looks like we just did the previous question. Area is x, y. Which letter can I get by itself pretty easily? Oh, y. Plug it in. What's going to happen? We're going to get x times 60 minus 2x, or if we expand and put in the right order, we have an equation for area. I want to find my axis of symmetry. Let's put it over here. Negative b over 2a gives us 15. I want to find y. We know that y is 60 minus 2x. That's what they're told up there. So 60 minus 2 times 15 gives us 30. So there is a max area when, what do we figure out? X is 15 and y is 30. Okay. Our homework today is at the bottom of the handout. There's a couple questions there. I think there's 5. Okay. They're based on some simple shape ones, some money problems, and just a numerical problem. Okay. Our big objective is to find maximums and when they occur by using our equations that we built or that we were given.